Welcome students, my name is Teacher B. I'll be taking you through mathematics, specifically Kcse distribution, past questions. Feel welcome. If you have any question, just ask in the comment section and I will respond to it appropriately. Okay. So, we have question number 1. The gradient of the curve y is equal to ax squared plus bx at the point 1, 5 is 7, where a and b are constants. Find the value of a and b. Now class, remember we have been given the gradient function. The gradient as 7 and the function of the curve or the equation of the curve as y is equal to ax squared plus bx at a specific point 1 at the point 1, 5. What you need to understand is that coordinate is going to be written in the form of the displacement along the x-axis, then followed by the displacement along the y-axis. By definition, it means that 1 occupies the value along the x-axis and 5 the value along the y-axis. And therefore, it will be as true as when I say 5 is equal to a multiplied by 1 squared plus b multiplied by 1. So we are having the function of the curve is 5 is equal to a multiplied by 1 squared plus b multiplied by 1. So we're having 5 is equal to a, 1 squared is 1, so 1 times a is a or a1, 1a, plus b multiplied by 1 is b or 1b. And call this equation 1. Then class, you have been told that the gradient of this particular curve at this particular point is equal to 7. And therefore, you need to differentiate the curve, the function of the curve, to get the gradient function of the curve at this particular point. Then that is differentiation. By power rule, dy over dx is equal to 2 multiplied by a, then x squared minus 1, plus, we are having 1 here, we multiply 1 by b, multiplied by x power 1 minus 1. So dy dx, which is the gradient function, is going to be 2 multiplied by a is 2a, then 2 minus 1 is 1, so x power 1 is x. So 2 multiplied by a multiplied by x is 2ax. So dy dx equals to 2ax plus 1 multiplied by b is 1b, then multiplied by x raised to power 1 minus 1. 1 minus 1 is 0. Any number raised to power 0 is 1 by law from the laws of indices. So 1 multiplied by 1 multiplied by b is what? 1b or b. But now, this being our gradient function, we have been told that the gradient at the point 1, 5 is equal to 7. Meaning that I can as well replace the value of x with the coordinates, which is 1 there. So we're having 7 is equal to the gradient 2 multiplied by a multiplied by x, 2 multiplied by a is 2a multiplied by 1, which is from our coordinate, is equals to 2a1, which is 2a plus b. Now here we are having two equations. Our second equation, 7 is equal to 2a plus b. Then you solve for these particular equations simultaneously. You can either use the elimination method or use substitution method, or you can use the matrix method from the form 3 concept. However, to save on time, because time is also part of the exam, just use any simpler method between elimination and substitution. That is, we are having 5 is equal to a plus b, 5 is equal to a plus b, and we are having 7 is equal to 2a plus b. So class, you can either make a or b the subject in any of these equations. Let me make a the subject in equation 1. I will have a is equal to 5 minus b. Then you come to the second equation and replace the expression of a with 5 minus b. So I'm having 7 is equal to 2a, but what is my a plus? 5 minus b, and then plus b. So you're having 7 is equal to 2 multiplied by 5 is 10, and then 2 multiplied by minus b is minus 2b, then plus b. So if you take the 10 to this other side, you're collecting like terms. I will have 7 minus 10 is minus 3 is equal to minus 2 plus b is minus b. So the negative and negative can go. So the value of b is equals to 3. Now, what is the value of a class? Remember we said a is equal to 5 minus b. So a is equal to 5 minus b. The value of b is 3. So 5 minus 3 is what? Is 2. So the value of a is equal to 2. So our values of a and b respectively is 2 and 3. And that is the end of the question. Last question number 2. Imani has 21 coins whose total value is 72 shillings. There are twice as many 5 shilling coins as there are 10 shilling coins. The rest are 1 shilling coins. Find the number of 10 shilling coins that Imani has. The question is tested on algebra, formation of algebraic expressions and equations. And we need to just try and understand what the equation is saying. So we start by understanding the first bit of the equation, the first part, that Kimani has 21 coins whose total value is 72 shillings. So the number of coins is 21, but the value of the 21 coins is 72 shillings. Then the question goes ahead and says, there are twice as many 5 shilling coins as there are 10 shilling coins. Plus, the question is, do you know the number of 10 shilling coins that Kimani has? And the answer is no. So you say, you introduce a variable and say, let the number of 10 shilling coins, let the number of 10 shilling coins, of 10 shilling coins that Kimani has, the number of 10 shilling coins that Kimani has be equal to x. So x is just but a variable representing a value that is not known by us. And therefore, if the number of 10 shilling coins is x, and they are telling us that the number of 5 shilling coins is twice the number of 10 shilling coins, then it means the number of 5 shilling coins, is equal to 2x, because it's twice the number of 10 shilling coins, which is x. Then the last bit, the rest are 1 shilling coins. So if Kimani has x number of 10 shilling coins, he has 2x number of 5 shilling coins, and the total number of coins that he had initially is 21. Then what expression is representing the remaining number of 1 shilling coins? All you have to do is to add the number of 10 shilling coins that Kimani has plus the number of 5 shilling coins that he has. That is 2x plus x, which is equal to 3x. 3x is just but an expression representing the sum of the number of 10 shilling coins and number of 5 shilling coins that Kimani has. Then what expression is representing the remaining number of 1 shilling coin? So the total number of coins were 21. If you subtract the sum of the 10 and 5 shilling coins, which is 3x, you'll have the remaining number of 1 shilling coin that Kimani has. So here, what is the value of x? Now, by definition class, if you multiply the value of a single 10 shilling coin with the number of 10 shilling coins that Kimani had, we'll have 10 multiplied by x, we'll have 10x. Now we want to get the value. How did I arrive? How is it that the total value of the 21 coins is 72 shillings? Multiply the value with the number of coins. Then 5 shilling coins multiplied by the number of 5 shilling coins is 2x. You'll have plus 10x, because 5 multiplied by 2 is 10x. By 2x is 10x. 10 multiplied by x is 10x. And 1 shilling coin multiplied by the number of 1 shilling coin will have 21 plus 21 minus 3x is equal to 72. So collect like terms. 10x plus 10x is 20x. 20x minus 3x is 17x. And then we're having 21. If you take the 21 to this other side, we'll have 72 minus 21, which is equal to 51. Then to find the value of x, you divide this side by 17, also divide this side by 17. So x is equal to 3. And this is the number of 10 shilling coins that Kimani had. Question number 3. Two aircrafts, A and B, took off at the same time on Monday from Jomo Kenyatta International Airport. That is, the position of Jomo Kenyatta International Airport is 1 degrees south and 7 degrees east at 11 p.m. A flew due east while B flew due west. If if they met after 18 hours at 1 degree south, 117 degrees west, calculate their respective speeds. Now class, the question is testing you on the concept of latitudes and longitudes, latitudes and longitudes. And just a brief reminder here is that the concept of latitudes and longitudes is going to be used in calculation of distance traveled by either aeroplanes or traveled by ships. It's like another aspect of linear motion, though linear motion we are dealing with vehicles on land. Here we are dealing with objects or vessels in the globe or the space. So when you get such a question, it's important when you draft or draw or have a sketch of the globe. You have been told that two aircrafts A and B took off at the same time on Monday from Jomo Kenyatta International Airport, and the position of Jomo Kenyatta International Airport is 1 degree south and 37 degrees east. Remember, while describing the position of a place, you first of all state the latitude followed by the longitude. Latitude is the this is the angle is north or south of the equator, and longitudes is the angle either east or west of the prime meridian. And what you also need to record is that latitudes, the planes of latitudes are going to be perpendicular to the equator or to the plane of the equator. So here we are having this one, south probably here. This is our equator, imaginary one. This one is our prime meridian. So 1 degree south is here, 1 degree south. You can see it is south of the equator, and 37 degrees east. So east of the prime meridian. 37 degrees east of the prime meridian. So 37 degrees east is there. So our position at Jomo Kenyatta International Airport is at this particular point. Let me call it J. I can give it a name and call it J. And then this particular aircraft A and B departed at 11 p.m. We are told that air flew due east. No, this one is on the east. So this object, aeroplane A, took that direction, and B flew due west. It took this direction. So that is due east, and this one is due west. If they met after 18 hours at a different position, which is along the same line of latitude, 1 degree south and 117 degrees west of the prime meridian, we have probably a point here, call it 117 degrees west of the prime meridian. This one is the prime meridian. So class, remember, speed is going to be given by distance over time. And therefore, if I'm to calculate the distance traveled by object A first, distance covered by A, then I need the angle difference. Because A, we are told that A flew due east. It went that way. Remember, if a single rotation along the prime meridian, or when the earth rotates on its axis, to make one full rotation is 360 degrees. And therefore, if this particular object A moved due east, it made almost an angle of 360 degrees. And it didn't cover the angle formed between this particular point here and this particular point here. So if I was to bring it down to draw a 2D diagram, I will have and here, if this is J, let me call this particular point P. So I'm having J there, and I'm having P here, or interchangeably, JP. So the size of this angle here, because from here to here, the size of this angle here is going to be the sum of 117 degrees west plus 37 degrees east, which is, let me just use my calculator, 117 plus 37, we're having 154 degrees. So aeroplane A never covered an angle of 154 degrees, but the remaining angle out of 360. So if you take 360 minus 154, we're going to have 206. So the distance along a small circle, remember this one is a small circle, is going to be given by 200 theta out of 360, 2 pi r cos alpha. Because now what is our theta? Our theta is the angle difference, which is 206. 206 out of 360 multiplied by 2 multiplied by 22 over 7. And this r is the radius of the globe or the earth, which is 6370. And then cos of alpha, which is 1 degree. And our answer there, distance traveled, if you just use your calculator, you're having 22,908. 22,908.2882 kilometers. Now remember, speed is going to be given by distance over time, and therefore we just have to take this distance here, divide by 18 hours, which is approximately equal to 1,272 kilometers per hour. That is the distance traveled by A. What about the distance traveled by B? The distance traveled by B, it's only the angle difference that is going to change, because B traveled due west. It covered this angle here. From here to here is 37 degrees. From here to here is 117 degrees. So you just have to add, because when two, if these particular positions are on the opposite sides of the either equator or the prime meridian, you're going to add the R for you to get the angle difference. If they are on the same sphere, either north, or south, or east, you're going to subtract or get the difference for you to get the angle difference. So here we have 117 plus at 7 degrees, which was equal to 154. So it is 154 out of 360 multiplied by 2 multiplied by 22 over 7 multiplied by the radius of the earth, 6370, and then cos of alpha, which is 1. Then approximately, just key in that in your calculator, you're going to have 17,125.6135 kilometers. Now, the speed now, the question is the speed. Remember, speed is distance over time. Just take it, it took it 18 hours. So the distance covered is this one. The time taken is what? 18. Divide by 18. Divide by 18. And speed for B will be approximately 951 kilometers per hour. Any questions, class? This one has always been coming in the exam. You need to be very careful and do a lot of practice. You can organize a class next time. Just teach the whole topic. So a two-digit number is going to be formed. The question is, a two-digit number is formed from the first 4 composite numbers. Write down all the numbers formed. Now, class, this question is testing you on probability, and students and also, secondly, it's also testing you on are you familiar with mathematical terms? For example, prime numbers. For example, composite numbers, even numbers and odd numbers. And they'll be having problems with students whom sometimes tend to be a little bit cheeky and ask, Mwalimu, they asked me to define what a prime number is in an examination, situation. And the answer has always been no, they won't ask you. But a question will come that requires you to understand what a composite number is. A question is going to come that requires you to understand what a prime number is. And therefore, definition of a composite number, these are all prime numbers, all natural numbers that are not prime numbers. And the first 4 between 0 and 10 is 4, 6, 8, and 9. So you'll have to draw a table 4, 6, 8, 9. 4, 6, 8, 9. So the first one is 44, 46, 48, 49, 64, 66, 68, 69, 84, 86, 88, 89, 94, 96, 98, and 99. And these are all the possible two-digit number that can be formed. Maybe if the question went further and asked you to find the probability that the number formed is going to be an even number, then you need to find out how many even numbers are here. An even number, when you divide an even number by 2, you're going to get an integer or a whole number. So this one is even, this one is even, this one is even number, this one. So we're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of the possibility space. How many? 1, 2, 3, 4. 1, 2, 3, 4. 16. So you can simplify further. 2, 6. Here we're having 8. It is equal to 3 out of 4. So the probability that the number formed, that the number is going to be an even number is 3 out of 4. If they ask you of what number, then you're only having 1, 2, 3, 4. So you're having 4 out of 16. 4 over the possibility space, which is 16, and you can simplify further 1 over 4. That is the answer.